Inte tekniken, vi har inte gjort innan och sådär. So, good afternoon, everyone, and welcome to this live webinar with the DP Patterning. Today, we will introduce you in how to create a strategic change in the way of FlexPCB sourcing, from external sourcing to in-house production. My name is Staffan Nordlinder, and I'm CEO of DP Patterning. And with me today, we have Rune Gropfeldt, and we together will guide you through this webinar. Welcome, Rune.
Thank you. Thank you.
Please, Rune, explain for the audience a little bit about yourself.
My name is Rune Gropfeldt, and I am responsible for the business development at the company. I joined the company in 2016 as a co-founder, and before that, I have about 30 years experience of being a managing director for small and mid-sized companies in various industries. I have experience in chemical industry, electronic industry, glass factories, glass industries, and also from a couple of software industries within ERP and MES systems. Also been working with communication, navigation, and surveillance in the maritime market. I have built 2 factories, one in the chemistry industry and one in the electronic industries. I acquired a lot of experience in manufacturing and logistics related to those industries. And that's why I like our product. It's a machine. It goes into a manufacturing environment, and it's complemented with a very advanced software that is a platform, you could say, to bring in a machine learning in the future, which I believe is going to be the future of manufacturing. It's also attacking or breaking up the supply chain of PCB. Besides, it also contributes to a better environment. Thank you.
Thank you, Rune. Very thorough presentation and relevant knowledge for today's topic. Myself, I have a little bit more scientific background, technical background. I've been working as a researcher for over 20 years. And both as a researcher and a manager at the Swedish Research Institute, RISE. And RISE is also actually where the technology was developed 15 years ago. And it was developed as an in-house manufacturing process where we needed to find a better way to produce sustainable circuit boards for FlexPCB industry. And my research field is basically electronics and printed electronics, and with the production methods associated to that. So, Rune, let's jump into today's topic. You've been traveling around the world lately and met a lot of our customers. And what does the customers really need today?
Well, that is not true. I have not lately been traveling a lot. We know everyone that traveling has been restricted for some reason. But I used to travel a lot and meet customer on site. That is what encouraged me. The customer that we talk to today put, I would say, 3 topics that is of importance to look into. I have focused on, and of course, cost is always there. Cost reduction. That is what the electronics market is distinguished. But also there are 2 other. We do see an increasing interest to produce with a sustainability approach. We see especially in the automotive business, we see sustainability is coming along with the marketing for the OEMs, depending on the consumer buying preferences. The last one, I would say, is the discussion on the top floor today, and that is about the sourcing and the risk of sourcing within the situation we have on the market right now.
And why do you see this trends right now?
Oh, there's a couple of things that we are looking into, and that is, first of all, there is 2 big economies today which have a conflict, and that is the US and China. There is a trading conflict going on. There are other conflicts, conflict of interest on the market as well. India is a big company that also has a conflict with China. We do see those conflicts is creating tension, and hopefully we will, in the future we can release those tensions. The other is of course the experience we have of the corona. There are companies closing down. We have layoffs. We have lack of components, shortage, or delays of materials, and so on. So it's really a disruptive situation on the market. And if you look into the complexity, the logistic complexity of the electronic industries, it's very, very sensitive for those disruptions. So the strength of the network, of the logistic network, is not stronger than the weakest link. So if the weakest link is missing, then the whole system collapses, and that is what we have experienced today. Finally, I would say that the situation for the PCB market is that the dominating volume of PCB manufacturing is in Asia. 2019, almost 90% of the global volume on the market was produced in Asia, where China is representing more than 50% of the production. And of course, with this a little bit chaotic situation we have today, it is a risk for sourcing. And if we then add the natural disaster, storms, flooding, heat waves, and so on, then we have a situation we have to deal with in a different way. That's what I believe. So yeah.
And this seems to be a tricky situation to manage as a manufacturer today. What other challenges do you see from customer point of view, from our customer point of view, producers?
Well, I mentioned the floods and the storms and so on, and that is a part of the climate change we have. Despite what opinion about you have about the courses, we have a focus on the carbon oxide footprint. And that is something that today is also regulated, but also the consumer buying preferences is more of green, and which means that we need to have a focus on the carbon oxide footprint in the future when we are selling our products. And I know from the very beginning, Staffan, that for 20 years ago, you have the environmental situation on your mind when you developed the technology from the very beginning. So please explain a little bit more about your thought at that time.
Yeah, thank you. That's correct. I mean, even though 20 years ago, maybe carbon footprint was not the top of the manufacturer's list to prioritize, but in the field of research field I was working in, the printed electronics field, we saw that the newly upcoming printing methods for creating circuit boards was not rigid enough. They was not conducting enough. And we were looking into traditional manufacturing methods and saw that etching is the only relevant alternative at the time. But we would like to really find an environmental sustainable way to produce a circuit board. And besides that, we also would like to be able to do it in-house and next to our other printing equipment and chip attachment equipment. And that could not be done with an etching line due to the corrosive materials they're using, and also extensive footprint they have on machines. And by developing the technology for over 15 years as in-house production, we used it only for prototypes, research purposes. We developed the system to be a fully functional machine. Like 5 years ago was the first delivery of the full system ready for serial production. And that's where we are today. And the idea with this mechanical process is that we remove any chemicals at all. Maybe I can show you a short picture of how it works.
Absolutely, absolutely.
So Joachim, if you could turn on the video. Thank you. And here you see the simplicity of the method. It's only two pieces acting together. On the right-hand side, you have the patterning tool that defines the pattern you would like to create. And on the left-hand side, you have a mechanical cutter, more or less a standard cutter with specific precision and geometry, of course. But this is it. It's simple and easy, and it works perfectly well under wide variety of circumstances.
What is the gray dust that you see on the left side there?
Yeah, actually, that's the residues from our process.
Okay.
The residue from this process is a dry powder or chips, and they
Okay.
can be recycled. It's just a
All right.
powder.
Okay, that's great.
Yeah, that's really nice. And we feed the material with the system with the same material as for the etching line.
Okay.
More or less. And by removing the chemicals, as I mentioned, you saw the mechanical process here, we could actually bring it in-house, the production itself. And by doing this, it was not just the environmental aspects, but also the working environment. So made it possible to bring the production in-house.
Okay, so before you go into the details here, I would like you to present the machine in live, so we have a better understanding what's going on in the 360 machine that we are producing.
Sure, we can do that. Actually, we took this, I said, in-house production a few minutes ago. We brought it one step further. We brought it in office production. So we have the machine in our office, actually. So if you follow me, I will show you the machine. So here you see our old board meeting room. We removed the board and replaced it with the machine instead. We think that's much more funny. And as you see, the size, the footprint of the machine is not very big. It's like 6 meters long, 2 meters wide, and that's what you need for production. Compared to an etching line where you need to have multiple production systems in a row. One that printing the etch resist, one that I do actual etching and the drying and cleaning and so on. Everything in this machine, this is the core unit of the machine. Everything happens here in one single step. It's dry, it's cold process, and the acting part, as you saw on the video before, this is the green flexo printing plate, more or less. It's the same used in the printing industry. We like to keep the tools and processes as common as possible. So that's why we use this normal flexo printing plate.
So it makes it easier for the customer to
get hold of material,
okay.
The tools, and also to manufacture the tool themselves. And on the opposite side, you have the cutter here. And the rest of the machine is actually just material handling, material sourcing, putting it into the process area, and rewind the produced part in the other end. And in the midsection here, we have a possibility to attach a number of measurement devices or processing devices. So this is what we call an expansion unit. So here you can add electrical measurement, RFID measurements. If you produce RFID antennas, maybe we would like to have a radio measurement station.
So that's a lot of customization here. That we can think of. Okay.
Yeah, and the customization could be also for post-processing. Corona treatment of the surface, since you maybe would like to laminate later on.
Okay.
Yeah. And in the machine, you also have a camera system, high-resolution camera, 100% coverage of the web. So we film or record every square millimeters produced in the machine. And with this camera, you can measure the products you produce, dimensions, maybe you have a specific area of interest, footprint of a landing zone for a ship, or the outer dimensions. But it also can detect the quality and follow the quality of the produced parts.
Okay.
And in combination with the camera analyze, is sent up to the database.
Okay.
To store all data of each single produced part, and it will be marked.
Okay.
And in combination with the marking system, in this case, we have an inkjet printer. You can use any type you like.
Yeah.
You have full traceability of each single produced part in the machine.
So if I understand this right, there is one PCB laminate coming in.
Yes.
And there is one piece of laminate pattern coming out.
Yes.
And then you have the residuals, the chips.
Yes.
The aluminum chips.
Yes. So one material in, two out. One is the product. And we
So what do you do with the chips?
You can see here the chips is just using a normal exhaust system, collecting the chips in a bin, and you can see how it looks like. It's like steel wool, and it's pure metal. So this you can just melt down and send to the recycling company, and you get paid for it actually.
Oh, you get paid for it as well. So you have a revenue stream of the disposal, and you have a revenue created with the pattern PCB. That's what I like. That's what I like.
That's your business. Yeah. And today you see we're running on aluminum, and this is a very common material for RFID and heaters, but we also see growing interest in interconnection with aluminum circuits as well.
Okay, what else material are you
we can run most common available material for FlexPCB market. So we can run copper, but we can also run novel materials like copper-cladded aluminum, CCA, where you have the bulk is aluminum, and on top of that you have a thin layer of copper. So the electrical properties is from the aluminum, and the solderability properties is from the copper. So then it makes it possible for you to solder onto aluminum sheet with the standard methods.
Smart.
And here you also see that today we're running the cheapest material, aluminum on PET. But of course we can run copper on polyamide if you like that, for running it in standard reflow processes.
So what speed do you have here? What is the throughput of the machine?
It's really high throughput. The process itself is not depending on the machine speed actually. As an etching line, you have to wait for the chemicals to etch down into the material. Everything is done in one single process step here. In a fraction of a second, you remove the full metal layer. And this machine is set up to run 30 meters per minute.
All right, that's a lot.
Yeah,
that's a lot. Quite impressive.
Yeah, and the width you see here is 360, but it can be increased to 400 millimeters. And the printing length, revolution of the magnetic drum, is standard 800 millimeters, but can also be extended. And we fixed the tool itself. We talked about the cliche, flexo cliche before. We fix it with a magnet, so it's very easy to attach and detach the tool itself.
So how long time does it take to change the tool, sir?
A couple of minutes, 2 to 5 minutes. So very easy to change pattern. That makes it the machine. This is serial production machine, and since that's a fast changeover from one pattern to another one, you can use the same machine for prototyping. So you use the Friday afternoons for prototyping, and the rest of the week for production.
So I imagine there will be a conflict here between the production department and the development department. It's usually.
It's always like that. But then you can buy 2 machines.
Oh yes, yes, of course. I will remember that.
Yeah, good. Okay, so
could you please arrange so we can look at it in operation?
Absolutely, we can do that. First of all, I would just like to show you the HMI. And this is the operator panel. You can do everything from this panel. Everything is integrated in this panel, and that's quite unique as well for a system like this. So you have everything from recipe handling, communication with the MES system, superior system, downloading data, and also uploading results. And you can also have a vision system within the same panel, and you can have maintenance pages so you can reach each single function of the machine. So the first thing you do as an operator is that you download the product, and that could come from the MES system. And the only thing you have to enter is the batch number of the raw material roll, and then download the order from the system. But also we deliver this machine with several user levels. So as a customer, you can decide how much each single level can change in the recipe or how to operate the machine. But I know you're keen on seeing it's running. We can start it. So it's very easy. The only thing you have to do is attach the tool, already done. Start the web running, start the cutter, and as soon as you engage the cutter, you will have the first product will be a functional one.
Yeah, they can.
So here you see this is an NFC antenna produced, and we can ramp up the speed a little bit. I guess you would like to see it running faster. So this was 5 meters per minute.
Wow.
And now you can see it's running much faster. So meanwhile, the machine is continued to produce.
Yeah.
We go out to the coffee area again and continue the discussion. And today we have cheated a little bit with the cover here. Normally they have to be closed, of course, for production safety. Yeah. But I close them before I leave the machine. Like that. So over to the table again.
Okay.
But that was fun, right?
Mm. I like that.
Yeah.
I like machines.
Yes. And now we see that the machine is very easy to operate and run smoothly. Mm-hmm. And of course, everyone in the audience would like to know what does it cost to produce with this machine? How much?
Yeah, that's the question we get very often. What's the price and so on. But let's start with the cost of material. The cost of material is depending on what kind of metal you are using and the structure and the thicknesses also. On the high side, the more costly web PCB laminate, you have copper and together with polyimide. The thicker copper you have, the more costly it is. And then you have two options, either go with adhesive or adhesive-free laminates. And the adhesive-free laminate is rather more expensive than the one that's produced with adhesive. On the low cost side, you have aluminum and you have PET, for example, and you go thinner aluminum, you have a very, very cost-efficient structure. Actually, the cost for the copper polyimide is 10 times more or even more costly than aluminum on PET. If you look into the operational cost, we have three parameters here. It's the operator itself, the cost for the personnel. Now, this is an automatic machine, so the cost for operation, I think we can leave that for the moment. We also have cost for power, for the energy. We have a machine that is operating 10 times less consumption of energy than traditional PCB operation. But probably the most interesting part is the investment and the cost for the investment. And it varies very much. It varies a lot, and there is two reasons I will not public any prices or release any prices in the public area. And one of the reasons is that is respect for our customer. We don't want the market to understand what the customer is paying for our solutions. The other thing is it varies a lot. If you have the simple one versus you have the most advanced, it's depending on the requirement specification you are giving us, would like to have in terms of quality control systems, what kind of material you are processing, and so on. So and that is something that goes into the discussion after an NDA, and when we look into the business, we do the business review. And the third thing is the cost of logistics. Compared to the traditional way of producing PCB, there's a lot of materials that goes into the process. And the one of those is a PCB laminate, and that's the only one that we are feeding our machine with, as we understood just recently. And when you have a complexity of materials, that you also have increasing the risk, and which you had talking about before, the sourcing risk. And in order to mitigate that, there is an option to do that, and that is increase your inventory. So if you make safe that you have the PCB in your stock, you need to increase the inventory because there is uncertainty of delivery, but you also have uncertainty on the demand today because some demand is just not there, or next month you have a lot of demand and you would like to sell them. So you are increasing your inventory, and now you have cost for the inventory, you have a capital cost for the product that you are locked in, and you also have a cost for scrap if the product become outdated, because you have a huge inventory and you have a short cycle time. Then you come up with new design, and then you have old PCBs in your stock. So those things can be very, very costly. So those are the three things that we should remember. And the experience we have in talking to customer and building up the business case, we see that you save 75 to 95% of the cost for flexible PCB. Mentioned that we also know that in some areas the PCB is cheaper than processing flexible PCB, but now you can walk from the PCB, the rigid PCB, to flexible PCB by in-house production. Talking about the logistics here and the complexity of logistics, we have had this internal discussions about how this is affecting the carbon oxide situation. Could you please explain us a little bit more about that?
Yeah, of course, and it's quite easy to understand this logic. You don't have to ship the raw material long distances. We only feed our machine with one material. You don't need to have the storage of the corrosive etching materials. And by not shipping, you're saving a lot of energy, of course. And you produce where you should assemble the final product. So you don't have to ship it from the manufacturing site either. So you have two shipping ways you can reduce or cut completely.
Yeah.
And also, as you mentioned, we save a lot of energy by not heating everything up. We don't have any wet sections in the machine. We don't have to dry anything. We don't have to keep liquids warm. That saves energy. And you mentioned 10%. I think that's quite an accurate number. And of course, that will also lower the carbon footprint for sure. And one of the biggest advantages with this technology is that you can actually recycle, especially when you're talking about aluminum. You can recycle aluminum and have an energy saving 95% of the energy compared to producing a virgin material from the earth core. Yeah, so it's very nice.
Let me summarize a little bit here before we continue. So what I understand here, we have a solution that we have discussed cost reduction, significantly cost reduction. We have a solution that is contributing to sustainability by reducing the footprint of carbon oxide. And we also have a solution that is securing the sourcing by in-house production, right?
Yes. And sorry, we forgot one important thing in the beginning of the webinar. Beginner's mistake. Sorry about that. Of course, there is a chat in the webinar, so you can type in questions. Please do that. And we have a few minutes in the end where we can answer them. Yeah. And also this webinar will be available online later on. So if you miss anything, you can see it later on as well.
Okay.
Sorry about that.
No problem.
But now you talked about that we have the functionality of the machine and the system. And when you meet the customer first time, how do you get started? How is the journey for a customer with DPP?
Well, we start with Teams meetings. We have a lot of Teams meetings, and the first discussion is try to scope the problem that should be solved. So we set up a technical review. We look into and discuss about the designs. We discuss about the volumes and so on, and we also set up a discussions for a business year review, so we know that if there is a business here and that we can provide a proper solution for that. Those are the first steps that we take. And if we have a positive outcome for that, then we offer to produce a sample for testing or prototypes, so you can continue with the validation with the product from us to your applications, or even to your customer applications.
And that could be pilot production as well.
Yeah, that can be hundreds or even thousands of samples that we are providing you.
Yeah.
When we finish the validation program, and that's a kind of iterative process. It could take a couple of months, up to 2 years, depending on how many different samples or different products you would like to test. But if that has come out with a positive output, then we set up meetings where we try to define your specific requirements so we can configure the machine, and we offer you a proposals, and hopefully you order from that proposals, and then we start the manufacturing. Right now, the manufacturing lead time is 6 to 8 months, very much depending on the delays and the access to components on the market today. And then we ship the machine to your site, and we install the machine and finish the installation after 2 weeks.
Yeah.
Now we have a situation that we have an unexperienced customer for this process. So what kind of support do we get to the customer?
Yeah, normally when we do the installation and commissioning of the machine, we always have a training of the customer's operator. This could take place on site, but it can also start already in Norrköping, Sweden, since we have equal equipment here in Norrköping. And after that, we normally set up the processes and help the customer with the first runs to see that it actually have the right settings and find the best parameters for producing the customer's product with our system. And anyway, we would like to train our customers, operators, and designers to the level so they can work independently from us. And of course, we are always in the back to support you if you need help. But our goal is to have customers that can completely operate the machine and system on their own. And in addition to this, we of course also train the maintenance personnel. Mm-hmm. There is some maintenance needed to be done on the machine, and that can be trained on site, of course, and also in Sweden. And in the same thing here, we like to train the maintenance personnel to first and second level so they can do most of the maintenance tasks that is on the machine.
Okay.
And we can also support with remote assistance with this.
What about if the customer wants to implement new material? So how do you deal with that?
That always happens.
Always happens.
No, not always, but very common. That customer have enter into an RFID antenna, and it turns out with something more complicated in material perspective. And since we have a background as a researcher, and we have a very close collaboration with the Swedish Research Institute, RISE, still, we can use the research resources we have in-house also at RISE. And we can do quite deep tech analysis of materials, like metallurgy. We can do analysis of glue and polymers to find the best material combination for the customer's product.
Okay.
And we do that quite often, so we have experience with that. And we think it's very fun to develop.
So if the appetite is increasing when you get used to the machine, we have a body that we can support with new material and new product, right?
Absolutely. And that's also work the same with the design teams. Okay. We help the designers at the customer side to set up the first designs and what to consider. All processes have their own design rules, including our. And we try to guide the designers together with our design team to make the best designs to have it the best quality and yield of the product possible. Okay. And this is also when it comes to cliché manufacturing.
Yes.
We can train the operator on site to do their own tools, and we can also produce tools here in Sweden.
All right. I think we are heading not really in the end. We still have some time for questions.
Yes.
And
And I think Joachim has promised to help us to read some of the questions from customer.
Yes, sure. We'll see if my microphone holds up this time. We have a few questions. How can you guarantee that the parts holds the needed quality?
Yeah, that's set up in the system actually, and depending on the parameters you would like to measure, we can, with our 100% web inspection system, detect measure the dimensions and download it to the database for further analysis in your production system.
Okay. Another question is, can I use my existing FlexPCB design?
Yeah, absolutely. Since we come from the printing side of the industry, we are more like graphical industry. So what we need to do when we have a Gerber file or PDF file sent to us, not PDF, Gerber or a CAD file, we need to convert it to a graphical format that our machines understand. So that's one step. And also we always do, together with the customers, we try to help you to do some tuning of the designs to have the best results. But absolutely.
Okay, thank you. One more. Are there any systems currently on the market in serial production?
Yes, we have system on the market that has been going on for a couple of years, producing the PCBs. So we have experience for volume production. We have built 6 machines from the start. So we're quite comfortable with the equipment right now. We are challenging with new materials and so on, which we like as an engineers. So we have a lot of experience to continue to increase the company's business.
All right. There's a couple of questions regarding the tooling, the cliches you were looking at before. So the first is, what is the tooling cost?
That depends if you produce the tool yourself. You just have the material cost and, of course, the simple device to produce the cliches. I should recommend you to watch another webinar we produced last week called From Design to Production Within 45 Minutes, where you can follow the production of a cliche in one setup. There are different ways of how to produce the cliches. You can either do as we normally do here, using a photolithography process used in the printing industry. Very common, very easy, and extremely low cost if you would like to do repetitive productions. But you can also use like a laser engraver system, a little bit more complex, more investments, of course, but it is more digital, so you can directly from computer print the tool itself.
Okay. And that is shown in that.
It's shown in that, but I didn't answer the question. So the material cost here is hundreds of euros for a full tool here.
Okay.
So
yes, I think we should send the audience, those who are attending in this seminar, the link to that, so they have it.
So they can watch the same. And we can do that afterwards.
Yes.
I think it takes maybe 1 or 2 days before the link is up and running. So, and of course, you can always turn to any print shop that can produce these tools. The only thing what we have recognized is that you need to be accurate when you do the things. This is electronic manufacturing. It's you don't print newspaper. So the only thing is that you have to ensure that your supplier is reliable.
Nothing wrong with newspapers.
No. As long as they are digital.
Yes.
That was a long answer. Okay.
Yeah, long answers are good. We have one final question, and then I think you can wrap things up. It's regarding the raw materials. So where can I find raw material suppliers?
That you can do almost anywhere where you find laminates suppliers for flex circuit boards. You can use most available materials on the market, but the same here. Our process have certain criteria to work in the best manner, and etching has their best performance. We have suppliers all around the world, and we can help you out with our preferred supplier to guide you through this. And you can always find the local ones. So I think that's, and we would love to help you out with find the best material for your application. And we actually seen that since most of our customers are not used to produce the circuit board, FlexPCB circuit board themselves, they have bought them earlier. And that is a very expensive thing to buy. And now you can produce it at a very low cost. And if you change to aluminum, you can produce it even lower cost. And that's a drastic change in the mindset of our customers. And we think it's very successful for the customers we have been working with in the past. So, and then it was out of questions.
Yes, out
Good.
of questions.
Yeah, that's good. But to sum this up then, I think we have shown how convenient and easy the process is to work with, to implement, and you don't have to handle the chemicals. You feed one material in, you get one material out, you get paid for residuals. That's Rune's favorite. And that's, of course, makes it possible for you to do the sourcing in-house, production in-house. So you don't have to do external sourcing for components. That's, of course, lowers your risk. And you cut the cost dramatically. Like Rune said earlier, 75 to 95% reduction. And what we really like to emphasize as well, and it's a very important topic for the market, is that we can produce the circuit board in a sustainable way now, and environmental friendlier way, by not using so much energy, not so much chemicals like traditional industry, and recycle the residues. And in the end, we also see that you can put the machine next to whatever post-processing step you would like to have. Could be a pick and place machine, it could be a lamination machine, it could be, we can produce everything in this machine. You can produce everything from heaters, antennas, wires, you name it. So
I hope the audience find this introduction to the technology and look into the strategic aspects for this interesting. So I would like to encourage, if you want to contact us, you feel that you will take a further deeper discussion when it comes to the strategy and when it comes to the technology we can provide or the solution we provide, you are most welcome to either call us or email us. We have our coordinates in at the website, dpppatterning.com. By that, I think we said thank you. Thank you very much for attending.
thank you very much, and I hope to see you soon. Bye-bye.
Bye-bye. Take an apple.